Okay, so good morning. My name's Nigel Harneman. I'm from CloudBees, and myself and a colleague here, Stephen from Puppet Labs, are going to talk to you this morning about testing your infrastructure as code. So hopefully you'll find this useful and relevant, and we'll show you some ideas and some concepts that you may have seen before, or maybe it's new to you. So the agenda for this session is we'll do a quick intro as to who we are. We'll introduce the concepts of Puppet and Jenkins to you for those that are not familiar. We'll recap on what continuous integration is, and then we'll look at why you should apply that to your infrastructure as code. We'll show you an example pipeline for doing that, and then we'll have a look at some ideas on how you can extend from continuous integration to continuous deployment or continuous delivery. And then at the end, we've got some sort of links and things on how you can find out some more. So about myself, as I said, I'm Nigel. I work for CloudBees. I've been there for about 6 months now. Prior to that, though, I worked for Sky, the major broadcaster in the UK, where I did various roles from build engineer and DevOps and architect. But really, for about the last 9 years, I've really been interested in how you automate application build and application delivery. So, Stephen, do you want to say? You're not on.
Start. Morning, everyone. My name's Steve Thwaites. I'm a solutions engineer at Puppet Labs. I'm involved with introducing people to Puppet and helping people learn it and adopt good practices when using it. My background's in systems administration, and I used to, work with VMware and various network vendors and things like that before kind of coming to my senses about what the future was and coming to Puppet. So it would help me, we've got a lot of content, we've only got so much time, so it would help me if you could just help me identify kind of what your backgrounds are as well. So who here is using a configuration management tool? Good, okay, so I can make that part quick.
So who's from a dev background? Developers, okay. Who's from a operations or sysadmin background? Quite a few of you. Anyone here from an architecture background? Okay, not as many. Any project managers in the room? Oh, there's always one. Okay. For the PMs, this is about how you can do it quicker, faster, cheaper. And for the rest of you that are engineers, this is about hopefully how you can have a quiet life, go home early on a Friday, and drink beer. Okay?
Great. Okay, that's great. Thank you very much. So I guess Puppet was started because we'd been using various approaches to configuration over the years, and they've all had their shortcomings. So hopefully anyone's still doing manual configuration for everything, by the way, just setting things up manually. Cool, good for you. But I think no one's going to advocate to you now that that's the way forward. I think automation is there's consensus that that's the way forward for getting things done. Because manual configuration is prone to human error, of course, and it's just slower than a computer. Humans are slower than the computers. Lots of people are still using like Bash scripts and Ruby scripts and Python scripts and things to get things done when configuring systems. And again, they are way faster and arguably much more reliable than human beings are. But they do have their shortcomings because they can be fragile. They're kind of a one-use, often single-purpose script. And if you change much of what's running underneath it, which it's a different environment or a different operating system, etc., they can break and they can be difficult to work with. Those of us who've been using cloud and virtualization platforms for years have been accustomed to working with golden images, of course. So that's where you kind of bake all of your standards and goodness into your base image and then deploy that over and over. And that's good at day one. That kind of gets you over that initial kind of pressure of getting something out of the door. But again, you end up with a new issue of kind of maintaining those images. And of course, over time, you'll have a mixture of configurations out in your environment. And there have been, for years, lots of kind of enterprise IT solutions that kind of are made by the incumbent vendors, the big enterprise IT shops. And they often employ some kind of mixture of those above approaches. They don't necessarily do things very, very differently. But they do wrap support and everything else around that for you. That's why they're popular. And those aren't the only issues we've got to worry about. System administrators and developers, usually have to document their work, and that's usually one of the last things to get done, right? But if we could find ways to make that easier, more reliably good quality, then that would be a good thing. Making your work more reusable, so you're not actually having to begin each new problem or each new area that you work on from the beginning and having to design things from the top. Audit, to me, in this sense, meaning a traceable log, basically, of what's been done, what the state of the environment has been over time. Testing as well. Testing is kind of a well-established kind of principle for working with complex environments and making things more reliable as you move changes into production. But there are often, it's often, again, a sort of manual kind of keeping of things in sync. And of course, workflow, like how can we find easy ways of working together and making a common set of tooling useful for everyone to use. So, who here uses Puppet? Yes, excellent. So I'll make this real quick. So we are the most popular, arguably, configuration management technology that's out there, modern configuration management technology, that is. So it started as an open source project. It's been going now for just over 10 years. We just had a big party to celebrate that. And I work for the company that makes Puppet Enterprise as well. That's kind of what pays me to be here and of course for the development of the various projects as well. And we've had that since 2011. We're about to release our next major release of that. It's a huge active community. Lots of you are here today. It's great to see you all. And a lot of there is just still tons of innovation left to do, and there's still lots that we're delivering with every release that comes out. This is a space, as I'm sure you realize, which is moving at such a high speed in so many different areas. There's new tools emerging and new kind of best practices and things around that. So we're committed to delivering on and keeping up with that with every release we make. And it's very popular. We've got millions of systems being managed worldwide with Puppet, and of course, thanks to the community, of course, we have an excellent, an online repository of reusable content. So this reusability can be taken advantage of. And of course, over time, we've actually broadened our appeal so that it's not, began life on just Unix and Linux operating systems, but now more recently, across onto Windows, believe it or not, and now switches as well. We can actually run Puppet agents on Arista and Cumulus network switches, etc. But what is it really, for anyone who hasn't used it yet? It boils down to being a piece of software that kind of understands state on a system and can take steps to configure and remediate configuration on a system. So you've got that piece of software. But also you've got the language, which is basically the model of configuration of a system that complements that. So Puppet, people talk about things being written in Puppet as they would a language. And surrounding all of that, that's kind of the engine that kind of handles configuration of a system, but surrounding all of that, there is so many tools as well, ones which handle the data that comes into Puppet for it to work with, and the data that it publishes about what's just happened during a Puppet run. Tools around workflow, tools around code management, and things like that, and there's a lot of them. If you haven't seen Puppet the language before, make this really quick. This is kind of what it looks like. It's very sort of human readable, I think, at least. It's a specification. So here I'm talking about a root user and various settings on there, but it's all just kind of a specification. It's declarative. We're saying how things should be, much more like your documentation normally is, right? You're saying that this is how things should be on a system. But we do have some nice kind of what would the sort of behavior you might be used to in scripting or programming, where we can have variable substitution and things like that. And this gives us more flexibility, again, more reusability. You can take the same set of Puppet code and use it in different contexts. So that's the language. The software, I'll make this real quick too, but where it basically agent server based. You have an agent deployed on every system, and it will, on a regular basis, check into a centralized master system. So that, and it will do that by submitting a load of inventory, and the master will generate an end state for that system. We call that the catalog, and that's kind of important for today's talk because that is really like an artifact which is generated during the configuration process. That goes back to the agent. The agent enforces that configuration, and then a report is sent back to the master. But really, I just wanted to show you this just to show you that there is a cycle at work here, and there is artifacts being generated as the systems interact. We've probably all heard, hopefully in the room, the term infrastructure code. But just to kind of underline that, what you should hopefully see from the code example and what I've been saying is that infrastructure code is both the description of your infrastructure and the means that you use to implement that configuration as well. And because it is code, we can lean on decades of sort of best practice and evolution of good practice in software development. And that means we can make use of tons of tools and processes like CI, and that's what we're here to talk about. So just in case you do want to get started very quickly, there's more links at the end, of course, but one easy way to do that is to use PE. Of course, I'm going to say that right, but it does include all of this tooling together and ready to go. So if for no other reason, it's just a really easy way to get it all down onto a system and just ready to work with. Another good place to look for ready-made content and for kind of guidance when you're looking at like, how do I go about this, is the online Puppet Forge. That's the repository that has both an API and like a sort of storefront that you can use to look around good code examples from Puppet. And I want to call out this here as well, this GitHub repository, which is from my colleague Gareth Rushgrove, who works at Puppet Labs. This is like a module skeleton. This is like you can actually use the command puppet module generate. And this is like a slightly more modified version of that, but it's a much more sort of complete one in the sense that it gives you loads of prefabricated code from everything from like a guard file so you can monitor your directories for changes and actually run tests very quickly, all the way through to actually like framework acceptance tests, etc. So really worth a look. Nigel.
Thank you, Stephen. So who here is using Jenkins? Good. Lots of people. OK, so we'll recap a little bit on Jenkins for those of you that aren't. It is the #1 continuous integration and continuous deployment server out there. It's an open source project. It's been around similar time to Puppet. It's been around for 10 years or more. And it's got a very big and active community. I mean, all your hands going up is a good sign, because it just shows how widely used it is. Just some facts there. We recently passed over 100,000 active installations, and that's the ones that we can measure by people kind of installing updates and plugins, and there's bound to be more behind firewalls. There's over 1,000 plugins, which means it works with most technologies that are out there today, and that's not just application development and code, it's also infrastructure and other things like databases and virtualization technology. It's growing fast. We see roughly about 1 plugin a week, building on that 1,000. And in the last year, we've kind of had 34% increase in the number of active installs and 64% increase in the plugin downloads, so still massively used. And the reason really for that is it is open and extensible. People find ways of using it to do the jobs that they need to do on a daily basis. And just to sum up on that, a recent survey by Rebel Labs showed that Jenkins was used by 70% of Java projects. It's kind of one of the most widely used tools behind JUnit. So who are CloudBees? Well, we're the Enterprise Jenkins company. And we can say that because what we do is Jenkins. Kazuki Kawaguchi, who invented Hudson and Jenkins, he works for us. He's our CTO. And we have got a huge amount of in-depth skill in Jenkins. So not only do we provide support for you as an enterprise support offering, but we also extend Jenkins with the CloudBees Jenkins Enterprise platform, which adds extra features. And really our business reason or our business value is really to help businesses improve their agility. And you hear this phrase, the business IT alignment, because we want to help people develop software better and faster. And ultimately, that delivers the business benefit. So a couple of quick words about Jenkins Enterprise from CloudBees. So we provide professional support for your whole Jenkins platform with our experts and expertise that we have. But we also extend it to provide things like high availability, to support you when you operate at scale. We have customers that are running maybe 6,000, 7,000 jobs on a master, configured on a master, but running on many slaves. And we've got a number of plugins that help achieve that. We also have organizations, especially in things like finance, that worry about security very heavily. I mean, we should all worry about security, but these guys often have quite stringent compliance requirements. and we've got a whole suite of plugins that enhance things like role-based access control, etc., which helps people kind of meet those security requirements. And as you scale, performance can kind of be an issue, and so we've got a number of plugins that help increase the resource effectiveness, as it were, in a larger state. And then finally, we have the sort of plugins like Workflow that support continuous delivery, and that's one of the things we're going to talk about and show today. So I said high availability, you don't want the platform to go down, you're going to depend upon it, you're going to use it for doing things like infrastructure deployments through to production, it needs to be reliable. We talked about security. There's different ways you can secure Jenkins, but they're quite painful to use. We've got a simpler mechanism using roles bound into your LDAP groups or whatever that just makes it really simple. But then as you scale, how many people have got many Jenkins servers running in their organization? Each team got their own server? Oh, okay. Each department. We kind of find Jenkins sprawl. Many Jenkins servers crop up. They're all configured differently. They're all running different plugins. It's kind of hard to manage. And then eventually somebody says, hey, let's give it all to the operations team and let them look after it. And then they're left with all this variability. So we have an operations center that sits across the top and allows you to get a single kind of management view across all of your Jenkins nodes. And some of that is down to things like monitoring and visualization. We've got a great analytics engine that collects all the build stats. So how long you're waiting in a queue, how busy certain slaves are, how busy your masters are, so you can manage. And it's brilliant when your boss comes to you and says, hey, we're doing the budget for next year. Do I need to buy any more kit? How much do I need? How many more slaves do I need? How many more masters do I need? And you're left going, was it slow last Thursday because of what the developers did, or was it because we ran out of infrastructure? Well, this would actually give you those answers. And the other thing that CloudBees does is it promotes the community. We contribute a lot back to the community, like the Workflow plugin, but we also run things like the Jenkins User Conference, which is there for open source users to come and talk to each other and learn and share, a bit like the sort of thing we're doing today. And alongside that, we run the Continuous Delivery Summit. So if anyone's interested in that, we've got some leaflets outside. Do pick them up. Okay, so that's the pitch over with. We have to do that as we're kind of being paid to do this stuff. Let's move on to the meat of today, continuous integration. So what is CI? What is continuous integration? Well, ThoughtWorks kind of surmised it pretty well in this statement. It is a development practice. It requires you to integrate code into a shared repository frequently and often and run some automated tests against it to check that it's all okay and spot problems early. So those of you from an admin or infrastructure background, you're going, develop? Isn't that the guys in the other side of the office? Well, actually, as Stephen said, we actually develop our infrastructure these days. We don't sit there at the UI and kind of bash away configuring a server. We write scripts, or we write things in things like Puppet and other tools. And that is development. We go through the typical cycle. What's the requirement? Okay, let's implement something. Now we need to test it, and then we need to ship it to a higher environment to use. So, the dev teams are a fan of CI, and they say that ops should be doing it as well. Okay? I think that's probably a phrase everyone hears. But, how does that apply? Don't I just build it by hand and test it? Well, not today. That's not how we do it. Because if you do deploy the app and test it, does that test everything in your infrastructure? Is the server patched correctly? How many times have you kind of found out a week later that there's some kind of hidden issue that only comes to light? Do all your admins have access? Did you forget to configure that when you set the server up? Did you disable the guest accounts? I mean, how many of you pen test every single server that you build? Or do you kind of pen test once every so often and spot the errors that way? Maybe that's too late. Did I configure DNS correctly? What about NTP? Have I got time drift occurring? Have I got my management tools running? You don't want to find out they're not running when you've got an incident and you're trying to investigate. And there's bound to be lots of other things that don't crop up immediately. The app looks like it's running, it's all good. But actually, you've got a problem behind the scenes. So what does CI actually do? Well, in a dev world, we would talk about checking into source code control like Git or SVN or any of the others that you use. Then doing a checkout, running a compile, running some unit tests, maybe doing some static analysis with PMD or Sonar or one of those tools, and then we build a binary and publish it. So, got all that. So more generically, we're going through this cycle of commit, build, test. So actually, that can apply to operations as well, can't it? So we've got infrastructure as code that Stephen's talking about. We have Puppet modules and manifests, they're code. We can commit those to a source code repository. I mean, you guys do that, don't you? Or how many people just keep it in versioned file directories in the master server? Yeah, we should be using source code control. You know, we want to be able to track changes and revert. How do you know your Puppet code's valid? Well, you can use tools like puppet-lint, which Stephen's going to talk about a bit more. How do you know it actually works? Well, there's test tools like RSpec and Beaker. You can run those and test the code. But you don't want to do that by hand. You want to do that automatically. You want to do that on every commit. So CI is as relevant to infrastructure as it is to application code. I think this is where we hand back to you, Stephen, to talk about the testing tools.
It is, thank you. So, as I mentioned before, these modules of Puppet code that you can download and you can create are, generally speaking, just a directory that has a particular structure, but that contains Puppet code and lots of the assets that it uses. And we want to be able to work with that in a way and develop in a way that means that we know about the quality of what we're delivering every time that we can make a commit, as Nigel was saying. And broadly speaking, when it comes to the test frameworks available for Puppet, we've got good coverage, and it kind of falls into these kind of areas that you might be used to seeing from development as well. So we have, you're going to be concerned about checking your syntax. Like, did I miss that semicolon? Did I miss that comma? I don't want to be able to either commit my code to a repository if it's just insane. It's just not going to run. Beyond that, though, there is like a style test that's possible. Does my code meet good style guidelines? There are actually style guidelines for Puppet that kind of make your code more readable, more easy to work with, because obviously the more that these things are shared, it's better that people kind of adopt a style that's common to everyone. So we want to be able to test if its quality against style there too. We want to be able to test that catalog. I mentioned before, the catalog is that configuration which gets sent back to a Puppet agent so that it can run. And if we can be able to look into that, we can actually generate that artifact and perform some unit testing on that without really having to take things any further if there are problems there. And ideally, and if we want to be especially thorough and be particularly confident in our results, we want to be able to do some acceptance testing. So does this actually perform an automated task that runs, takes your code, runs Puppet all the way through, and looks for a particular result on the test system it's deployed? Now, some of these tools you might actually want to have on your Mac or on your development system, okay? So you might use them in Git hooks, for example, because it's very cheap and quick and easy to run them, to just make sure that you're not able to commit or even to try and push anything from your system. Or you might even have it in Vim or something like that, so that when you write changes, it's just going to make sure your syntax is sane. But you're always going to want to make sure that server side and on the testing side, that all of these checks are being performed as much as possible. So both can be used in tandem, but the idea is, of course, that you want to get as early feedback as possible. You want to know as early as you can while you're sitting there, so you don't have to go up and get a coffee and break concentration. Is this same code? Is it going to commit okay? Is it stylistically okay? And is it going to deliver a good result? So we've got some tools to do that. So built into Puppet, we have syntax checking. Of course, Puppet does interpret the syntax, so it's in the best position to kind of let us know whether or not it's crazy or if there's a simple mistake been made. So this is built-in functionality in Puppet. You've already got it if you're using Puppet anyway. So this is, we can just run the command puppet parser validate and then just pass it the name of a Puppet manifest that we've written, and it will exit 0 if everything's cool, and it will not, and tell you why if there's an issue. So very simple, and that's the sort of thing you can put into a hook. It's the sort of thing you can, run against your code on your system. It's very cheap and quick to get that kind of feedback. But beyond that, we can move on to the style testing. So puppet-lint, the links and stuff are available and at the end of the talk. But it's basically an automated tool for testing your code against the style guide. The style guide is published and it's open and it evolves over time with the language. But puppet-lint keeps up with that, and it means that you can actually run your code up against that to make sure it's stylistically okay. And that can be things like, is it 80 characters wide or something silly like that? And just, how much does that matter to you? So some people you want to have that test right at the beginning because every commit I make has to be stylistically perfect. But for other people, maybe a lower priority. You might want to put that into late into your testing because what matters is it's functionally okay, and later on that you can worry that it's stylistically okay. But that's down to you. The tool is there available for you. So unit testing. So this is where we can tell Puppet that it's in some sort of scenario. We can say, like, a system is checked in. It's provided these parameters. It's this type of system. Make all of these assumptions and generate a configuration. And then we can actually generate those configurations and look for the results inside them. So if I'm trying to write a module that installs a database server, like let's say MySQL or something like that, I'm going to write that module and I can write a test to say, is it actually going to send down to the system a configuration that delivers a MySQL package? And then if you're working in a complex scenario where multiple modules rely on each other, or I'm working in a large team of people who all make contributions to this code, you will know if something that they've changed has messed up the delivery of this functionality from your module, because this test will be checking to see whether or not the config delivered is actually containing the right attributes. In this case here, this is just a snippet of kind of what the syntax is like for when you're writing these style of tests. And here we're just working with like an Nginx module. It has what we call a defined type in it because we're handling, we're sort of showing Puppet in the module how to handle its configuration. And then, it's quite sort of readable. It's got this kind of syntax, right? It should do this or it should not do that, etc. under those circumstances. And again, you'll get some nice feedback from that tool, telling you exactly where it failed and why. But it's worth remembering that these tools take a little bit longer to run, right? It's not just a matter of looking for certain syntax and stuff. You actually have to, bring together this environment and actually run and compile the catalog. So it takes a bit longer to run, a bit longer to get that feedback, so better put into CI. And this tool, Beaker RSpec, so the RSpec sort of framework for testing it with Ruby. But everyone remember Beaker from the Muppets, right? Exactly, yeah. So all of the meeting rooms at Puppet headquarters are named after the Muppets, by the way. So are a lot of our tools. So Beaker's actually a general purpose black box acceptance testing framework. So Beaker on its own can be used for almost any kind of scenario. And we actually use it for testing the entire Puppet Enterprise stack, all of the tools that go into that, the databases, the actual master and Puppet itself, as well as the code. But Beaker RSpec allows us to work specifically in the context of module testing in a familiar kind of environment for users of RSpec. So this is for real. When you actually define your tests in Beaker, you tell it about the platforms that you're going to test your system on. You kind of give it the details of a backend that it's going to be working with. So it will actually take your code, deploy a Puppet master and an agent on the operating systems that you specify, on a backend that you specify. So that can be AWS, it can be VMware, Docker, VirtualBox, Vagrant, whatever you like. And then it will bring your code down into that environment, run Puppet so it configures the system, and then run tests against the configured system to see, is the result really there? So very, very high degree of confidence after this, if you have a clean test, that this is going to work for you out in production. But this is more expensive. This is more time, if you like. So this isn't necessarily something I might do on my Mac, especially in more complex environments, right? It takes more time to get this feedback, and if it's a complex environment, even my Mac couldn't take it. So this is why we can just ship it off to some kind of solution. Have Jenkins just invoke this test and kick off something in the cloud that can let me know about its success later. But it's the most reliable.
Okay, so those were the bits. Those are all the tools that we would like to use in our pipeline. So let's think about a pipeline. So I'm going to stand over here so I can use my pointer. Sorry for you guys over there, but I'll try and talk about what I'm doing clearly. So here's your development person, your ops guy who's developing your Puppet modules. Should he commit to the master repository straight off? How many times do you get bad commits that then, and half an hour later, you find out the tests have failed, but meanwhile, other people have been checking out from the main repository, and they've now inherited the bad commits, and they're going, why does this not work? And they're troubleshooting. So one of the approaches that we kind of propose is having a pre-flight repository that you can commit to. And with one of the features in Jenkins Enterprise, you can set up a Git validated merge feature. And so what we do is you have a pre-flight repository that's hosted on Jenkins, which receives the commit. We then set up a Jenkins job that will run based on that commit, and it will run a subset of the tests that you care about. So as Stephen said, you're not going to run a 2-hour test that spins up a load of servers and is really complex and slow. You're more likely to run things like the validate, the lint, maybe the RSpec that just compiles the catalog, although sometimes they can take kind of 45 minutes plus to run. But you'll pick what is the fast set of tests that you want to get response on within the sort of 5-10 minute time frame. And the thing that's going to catch most of the trivial errors, the typos, the problems, we forgot to commit all the files associated with this module, we've left some out. And you run that set of tests, and Jenkins will give you the red or green light. It will tell you whether it passed. But the great thing about the validated merge is, as part of that job configuration, it will then automatically merge it to the upstream repository, but only, obviously, if it passes. So it's like a guard, it's like a gate. If somebody's been a bit silly, forgotten to commit something, it's not going to break this main repository. So meanwhile, anyone else can be checking out from here knowing that it's fairly sound. It compiles, it works. Once Jenkins merges to that main repository, what we then suggest is that you have a regular Jenkins job will detect that change and then rerun a more thorough build. So you may just repeat some of those tests for out of thoroughness, but then you may extend it and add in things like the beaker tests, which actually spin up some VMs. So this build might take considerably longer, but it's more thorough. So the end result is, for your module that you've built, you're pretty confident that it's going to work. It meets the acceptance tests, it can deploy to your target operating systems, it works. And at that point, you would then tag back into the source code repository to say, here's a good build, and it's got this build number. So that's kind of the pipeline that we'd recommend, and just summarizing it up. So it's pre-flight, dev the change, commit to a staging repo, do some validation against it, fast build response, merge up to the main repo, run the main build. That's more thorough, more complete, tag. Now we're going to show you. This is where all best laid plans go wrong and the demo breaks, but we will give it a go. We were working on this till quite late last night. Very late, in fact, this morning. So my Puppet tests are here. So I've got a module, which is the NTP module. It's the standard Puppet Labs NTP module that's available on GitHub. So I've taken a fork of that, and I set up a pre-flight build. So my pre-flight build is the one with the validated merge. So I've got this extra repository that's configured that I can reference and make use of. So I'm going to try and make some edits. So what I'm going to do is I'm going to break this. I'm going to make a lint change that causes it to break, which is really silly. But I just comment out that line and put some rubbish in. And then I'm going to commit as a breaking build, and I'm going to push. Now what you'll see I'm doing here is I'm not pushing up to the main repository. I'm pushing to this. I've got two remotes configured. I've got the main origin for pulling down, and I've got the Git validated merge repository for pushing up. So it's kind of going in a triangle. So I'm now going to push that, and what we should see is that build starts running immediately. It's running on Jenkins. Jenkins is hooked in. It's detected the change, and it's running. And it's actually detected that I'm the one that pushed it, so you've got the full trail. If we look at the console output, I'm basically running a lint, and it's failed because there's a syntax error. So the great thing is that hasn't now polluted the main repository. So now we'll go in and fix that change. Put a comment in. So we'll find my commit that says we're fixing it, and we will do a git push. Looks like it's already rebuilt itself. I think there must have been two pushing. Okay, it's going to build again. But it will go blue, and that will then merge upstream. So if I look at the console output, you can see now that it's doing a push. It's now pushing it up to GitHub, to the main repository. That's all done. So what will happen now, he says, fingers crossed, I clearly haven't got webhooks configured from Git to here because I'm on a variable IP address and I haven't set up dynamic DNS and all of that stuff. So that will poll and trigger, but what I'll do is I'll just trigger it anyway. But what this one is going to do, if I show you the configuration, all we've done is added in a number of build steps in here. So I'm actually running lint, which is using rake to wrap it, and I'm then running the spec tests. But I mean, you can put in here the rake steps for validate, you can put in the beaker stuff, you can put in whatever you want into this build job. So with a bit of luck, yeah, that's running. It takes quite a while. Ultimately, that's going to go through, and at the end, it's going to tag, so I can show you on my main repo here, you can see my tags from the previous builds that I was running this morning. So we only get a tagged build if everything is successful. So that's passed not only the developer pre-flight build, but it's also gone on and run a more thorough set of tests and then published it and said it's a good module, it's a good version, you can now make use of that in other recipes. Good. So that bit of the demo worked. I'm not going to wait for it to finish because that takes a couple of minutes to run all those tests. So we'll kind of move on to talk more about continuous delivery. Because all that's done is it's published a module. It's not really deployed it into staging and test and production and all of that stuff. So who's read this book? Did it send you to sleep? It's quite a big book, isn't it? It's actually a very good book, and it's really the seminal text on continuous delivery. And the key thing that this talks about is done is no longer, I've built a module, I've produced a WAR file or a jar file. It's about having tested it sufficiently so that you can ship it to production. Now, there's a debate about whether continuous delivery is the Etsy, Facebook style of you make a commit and half an hour later it's running in live automatically. That's continuous deployment. It goes all the way through and it gets deployed. Continuous delivery is really about a software methodology that's saying it could go to production at any point. And so it's this little distinction, but I think not all companies are as brave as some of these unicorns out there. They still want to have a release ready, and then they want to go through their change control procedures, and only when they've got change approval do they hit the button. But the key thing is, though, is all you've then got to do is hit that final button. It's a decision. It's not actually doing anything to put it live. It's go, and then it happens. So really done means at any stage you're shippable to production. And so if CI was just doing commit, build, test, what does continuous delivery mean? It actually means being able to go from dev all the way through to production with automation. So we then start to add on after the kind of, I don't know, whatever you call the functional testing or the QA that you do, further testing. So that testing could be performance testing. It could be vulnerability, security scans. It could be whatever in your organization makes sense. And ultimately, you'll probably deploy it onto a staging platform, which is your last chance to, I guess, make sure that it works with all your monitoring tools and things like that. Personally, I would still bring those tools earlier in the life cycle, fail early, fail fast. But sometimes staging still sits there for a reason. And then you get to production. And I've done this. 5 or 6 years ago, I had a system that, okay, we had to manually make decision points to go, but we ran the same scripts across every environment, including into production. And we ran it every week, more or less without fail, life was easy. And so I really do strongly believe that this is the way to go forwards. So how are we going to do that? How do you do that with Puppet? So Stephen's going to talk about a module called R10K, which hopefully we'll show you, and then we'll come back and do a bit of a demo.
Yeah, thanks. So, so we've talked about Puppet language, modules, putting those modules together, testing those modules together, and those modules are kind of like a really useful unit for for working with Puppet code. But now, when we're talking about this kind of staging environment and CI context, we need to find a way, or have a way, of describing an entire environment's configuration in a very precise way. So I may have, some of our users and customers have, 20, 200 plus Puppet modules running on their Puppet masters. Now, one of the nice things about Puppet is you can subdivide a Puppet infrastructure logically to serve different environments. So you can say that this group of modules here is serving development, this here is serving QA, etc., and we have our production ones as well. But what we'd like and what we'd need to work in this way reliably is to have a means of describing the makeup of that environment. So, for example, in production, I will have a set of modules which are at the stable release, for example, and in QA, all of those modules will be at a slightly more advanced release, which is going through testing. And in development, this will be where the latest and greatest is being tested out. And this is what we have in R10K. So this is a tool and a method for working with Puppet code across multiple staging environments. It gives you very detailed control over what modules appear in each of those environments, whether that's which branch you're using of the module in each environment, or which commit ID, right to the commit ID of every single module if you want, or indeed a tag or anything else as well. And it can be used with Git or SVN, incidentally, so we have means of working with both. But really what this is going to do is automate the process whereby when I want to move into a new environment or deploy a new environment, even for just like an automated process of testing even, it will go away to Git using a file that specifies the location and version of every Puppet module in that environment and automatically pull that in so that everything can be at the exact version you want to test. We've just added it to Puppet Enterprise as part of the supported stack, I guess. It's called part of like an area of the solution, which is going to be called Code Manager. But it really begins with R10K. It's all built on top of that. So you need to have that R10K tool. It's a Ruby gem, incidentally, so it's easy to download and use. And you need a Puppet file. So I will show you one of those shortly. So we have those ingredients. But moving on from there, what we can then do to automate in this kind of context is even put that Puppet file, that artifact that describes things, into a version control system and track changes and collaborate on that. Now, the way that the R10K works is that you will generate a branch for each of your staging environments. So you may discard the master branch and actually instead have a branch called production, a branch called staging or QA, whatever you call it in your organization. And R10K will look at the branches available on the repository that controls the Puppet file, and then use that to populate your Puppet master with all of the environments it uses, all at the exact version that you specified in each branch of that Puppet file repository. So it all gets a bit meta at this point, because you're talking about kind of Git handling version control of version controlled artifacts down on a Puppet master. But these layers kind of work really nicely together, especially in CI, because you're really having very fine-grained control and very transparent kind of visibility of the makeup of your environments.
And I guess the key thing from my point of view and my background in building these systems is I hate the latest. We built to the latest spec of the server this week. What are you going to build next week? What happens if a server dies and you need to rebuild to latest? Latest is no longer what you built last week. So the great thing about R10K is everything is version controlled, everything's got unique IDs against it, everything is repeatable, it's always immutable, which is a brilliant tool. The thing with R10K is it's really a bunch of commands that you run. It hides all of that mirroring and moving around of the repository and creating the environments and all the correct manifests, but you still got to drive it by hand. And what we're here today to talk about is automation. We're trying to take those things out. The intelligence is setting up the structure, not sitting there every day running it by hand. So we need an orchestrator of that. We need a pipeline that sits on top of it and actually drives all of those individual commands, but maybe actually does things like adds a bit of human input. Again, we talked about it wouldn't go to production until perhaps somebody says, I'm ready to go. So what we can do is we can extend the pattern. So we had the pipeline on the left, which was this bit here. It's slightly disjointed in that you might have many, many modules that go into your actual environment. So you've potentially got, I think as Stephen said, 20, 30, 40 modules that you could be building. You might have something for NTP, something for DNS, something for your package manager, and then you might have a web server, a database server, something that deploys your application. There could be lots of them. And they've all got individual tagged or git commit hash. They've all got unique IDs from the build cycle. Personally, I would always tag with your build ID as well, because you kind of want something that's a bit more readable than a git commit hash. But really what you're talking about here is having this control repository which has the underpinnings of R10K. So this says, for production, I need these modules at these versions. For development, I'm working with these newer module versions. For some of them, others will be the same as production. That's right, isn't it, Stephen?
Yes, yeah. That's right.
So really, it's kind of a manifest, think of it, in terms of what the environment's going to have in it. We put that into source code control, which means that if we make changes to it, hey, we can monitor it with a CI tool like Jenkins, and we can trigger a build. We can trigger a pipeline. However, the pipeline is a bit more complex than just running a compile and unit test. So you have to run the R10K commands. You then have to run the R10K provision. You might then run an RSpec test off the back of that and say, let's smoke test it. Did it work? Did it all look OK? At that point, you go, great, it's finished. But actually, your pipeline carries on, because you're going to want to promote that to the next test platform, potentially to production. You might actually want to stop and wait and ask for somebody to review it and approve it. Then you do the promotion. That's an R10K feature, which says, OK, let's move dev to staging. Then we run it again against staging. Then we do it again, and we run it against prod. And the way we'd like to think about doing that now is actually using the Jenkins workflow. So CloudBees wrote this and gave it back to the community. And there's a couple of extra features that the enterprise version has got. So to do a workflow, you need to have a complex pipeline. You need complex logic. It's got to be non-sequential. You might want to do things in parallel. In this instance, we're kind of doing it in series, but there might be things that you do in parallel. They can also take a period of time. You think about that going through test to prod, it might take a few days. It's not minutes. So you need to make sure that if you have an infrastructure wobble, you can restart it and it carries on. Humans will have to put input to it to approve it, make decisions. You kind of get the idea. So the new workflow job type really gives you a pipeline for continuous delivery. So you can set up the stages. These don't really map what we're talking about. They're taken from another example. But in this example, it would be dev to test to staging to prod, whatever your environment names are. And each release of your R10K manifest change will go through that life cycle and be visualized. And this visualizer is one of the enterprise features that we have, which is it's pretty cool. The workflow is a DSL based on Groovy. You can model everything in one job. People have been used to doing job chaining to do pipelines. You don't need to do that anymore. You can restart Jenkins while it's running. If it's running on a slave and you restart the master, it will reconnect and carry on. You can also allocate many slave nodes. So in this instance, we're just running on one, but you might decide that, say you were doing a regular build, you want to compile on a 32-bit and 64-bit, and you need different slaves to do that, and you can do that within the workflow. You can set up stages as well, so you can control how many builds can enter that particular stage at a time. And as we said, you can have human input. And that can be quite complex, from drop-downs and choices through to entering passwords, or could just be going tick, yes, carry on. And that's integrated with the access control, so you can control what users do it. And it's all built around Jenkins standard concepts. That's what the DSL gives you, very fast access to everything. So we're going to try and demo this. This is the bit that wasn't quite working this morning. Famous last words. So while Stephen connects the other screen, is it going to come up? Yay.
Yeah, you're right. Okay. So what we've set up in Jenkins is that we want to be able to pull down some code, spin up a system, run a test against it, and on successful completion, promote that and spin up the next stage. That's about as far as we got so far in our demo, but we're kind of short on time, so I'm going to whiz ahead. One thing I really wanted to make sure you saw is a R10K puppet file. Can people see this at the back? Good, thanks. Okay, so here we're just listing all of the modules that are going to be, that basically compose the environment that we're working with.
So do you have an example on there that shows the versioning? Because is that all latest?
Here in this case, yeah, we're taking a ref here, for example. So we could take a particular tag, or indeed, a particular branch, whatever the latest commit is in a certain branch, or indeed an exact commit ID. So I just wanted to make sure you saw that. This is the artifact which is describing the environments that we're working with. So I'll just bail on that.
So as you can see, it's a bit red.
Yeah. So we've been promoting and making changes all day. But if I run the command now, run the build.
So we're running this manually, but you could trigger it from an SCM change.
Fail on start. There we go.
Did it run? Did it fail straight away? Good demo.
Give me 20.
While he's fixing it, I'll keep talking. I'll do a dance. Anyone know any good jokes?
Yeah. There we go. Let me just come with that.
Basically, what we're trying to do there is simulate that you define what the staging environment looks like. It's going to run the vagrant commands, which that's actually the bit, basically the vagrant, not the vagrant, the puppet manifest that we've got has gone a bit flaky. But the idea is it would actually run the R10K commands. It will use vagrant to spin up a node and actually deploy to that node, given that environment. So that node is associated with an environment like development or testing. It will then call into Puppet as that environment, and it will then install the required set of modules based on that configuration file that Stephen just showed you, and then run a quick test against it. And it was actually our test that was failing. So in the usual case, we've commented out the test to get it to pass. And it was working, actually, just before we started this morning. But ultimately, once it's built, it will go green, or blue, I think it is, and it will then pause, and it will wait for human input. And what that's saying is we've deployed it to staging, we ran a smoke test, it looked like it was okay. If you've got now some manual inspection that you need to do, then go ahead and do it. Or if you're just sitting there waiting for somebody to approve going to production, it sits there waiting. And in this one, we did it here. We actually had it goes to a different color, a dotted line around it, and it's got a prompt on it. It shows you that input is required. You can then say proceed, and then it will run the next step. But I think what we should do is just show you a little bit about the configuration, what the DSL looks like. So in Jenkins, you run with slaves. Hopefully, you don't all run your builds on the master. It's not recommended for scaling reasons. So you need to allocate your steps to a node, and that's what this node syntax is doing. It's saying, I want to run this on my Mac, on the slave called Mac. And then we're running a whole bunch of commands here. Now, the stage keyword is what gives you the visualization. It's what controls concurrency. And then we're doing things like a git checkout, and that's just done using the very simple git DSL term. And then what this was really trying to do was run a whole series of shell commands that are running the R10K deployment. Because we're running it on Vagrant, we need to just set up the environment and then run it. And then we're running a Vagrant provision, which will actually start the node. And of course, then the node phones home to the Puppet master and says, hey, I'm node X. It then determines it's an environment. Which one's this? Test. And so it tries to deploy, it compiles the test catalog and deploys it and actually spins the node up. And then down here, which is a bit that we couldn't get fully working because of WordPress not installing, we're actually running a set of RSpec tests against it. And that's just running from shell commands. And then the key thing to note here is we can also set checkpoints. So if that passes and gets to that point, if somebody was to have a wobble further on, we could go back to that checkpoint and resume. And again, that's one of our enterprise features that we provide for customers. And then the input step was where we were asking if it's OK to carry on. You know, that was the pause. And you just define all of this in the DSL. I've actually got a version working on my laptop, which we're outside on a booth, that shows you actually a standard Maven build that goes through Maven, JMeter, Sonar, deployment to Tomcat, that shows this whole pipeline running. If kind of you want to see that, come and see us afterwards. But really what we were trying to do was show these two together, that you can use workflow to orchestrate on top of R10K. I'm just a bit sorry that we couldn't show the end-to-end. Do you want to bring up the summary slide? Because I think we're running out of time.
Just a few seconds. Yeah.
Have them run automatically thereafter. And Puppet is a great tool for doing that automation of the configuration and building your machines. It's really good for doing that. It means that you can treat your infrastructure as code. That's a buzz phrase that's around a lot, but you know, I really believe it. I've been doing it since about 2008-09. It kind of makes life so much easier. And Puppet is a great tool for doing that. But in developing that infrastructure as code, you need to test it. You need to follow a software development lifecycle. And that means that we should look to the technologies that developers have been using probably for the last 10, 15 years. You know, with the advent of Agile and continuous testing, tools like Jenkins have really come to the fore as the enabler of that pipeline, of that CI pipeline. But what we've shown here is that you can integrate that with the Puppet approach. And you can sit Jenkins with Puppet and automatically test your Puppet code. And then as you go a bit further and you want to move towards actually deployment and delivery, then you can extend Jenkins with workflow to sit on top of tools like Puppet R10K to make that a reality and implement CD. Now, we've got the slides here. They'll go out through the organizers, so you should all get a copy. And in there, we've tried to put the links to our GitHubs. We will try and fix these before you get them so that they will work. But the code is all there. And there's some more resources about us and CloudBees and what our products are and how you can find out a bit more. And Stephen's put the same up for Puppet. So we'd kind of hope that's been useful for you. That's it. We're right on time, so that means no questions. We can take some questions. But if you've got more, come out and see us at the booth, and we can kind of follow on out there. So, any questions? Stunned silence.
The morning after the night before, huh?
I realise they don't speak English. This is the trouble. We've just been talking for an hour, and...
Yeah, I'm kind of dislike this complex pipeline because what's about checking the code before the first, to commit the first time, first stage repository?
Yeah.
So, are developers able to run the whole test suite locally, script out from Git or whatever?
Yeah, there's nothing stopping you running those individual test suites anywhere. A lot of them are based on Ruby gems. Some of them just can be easily installed on the system you're developing on. I've got a lot of them installed on my Mac. And you know, this whole CD pipeline is really when you, especially when you want to, you're going to want something server-side, right? Of course, to make sure that everyone, regardless of whether or not they are doing checks on their Mac, the checks are being made. If you see what I mean. So you're always going to want that, I think. But if you want like really, really fast feedback, I think some of these early checks that I was describing, the syntax validation, the style validation, and if you want, maybe RSpec testing if you wanted to, can be done on your Mac quite easily, either as like a Git hook on your system, or there is a nice tool called guard that you can use. That module skeleton gives you a guard file, and what that will do is monitor your working directory when you start it for the file system, for any changes made to files of a particular extension, and then it will execute a custom command when it changes. So as soon as I hit save in Vim, it can execute the test suite but you'd be something you'd want to get back very, very quickly, because you wouldn't want to wait 15 minutes for VMs to be built with Beaker and things like that. So a combination of approaches, I think.
Yeah, I guess the key thing here is, I mean, in software development terms, your developers are supposed to run the full unit test suite before they check in. Maybe they're supposed to run a more complete build that spins up a personal environment, runs the database upgrades, and checks some things out. In reality, we all know that people cut corners and don't always do that. So there's nothing here that stops you from doing that, but this is like a repeat test that ensures that it has been done, it has been enforced, it's been controlled and done through an audited system with a build history, so that you make sure that that has to happen. I don't know if you ever have the silly hat that you wear if you break the build. Do you have those in your teams?
The sombrero?
The chicken hat or something. I mean, the key thing is, if you break the build, you have to fix it. And so if you commit without running your tests locally, you're probably going to wear the chicken hat and look silly until you've fixed it. This just adds an extra layer that says, before breaking the main repository for everyone, actually, why don't we go through a kind of pre-flight repository? You might still end up wearing the chicken hat because you broke this bit, but at least your colleagues can carry on checking out and working because you've still got a protected repository. The thing is, it's flexible. You can adapt this to your organization's workflow, and change it over time if you need to.
You will break it very often because you can't check all this stuff really.
Yeah, that's true. So yeah, if you have some basic tests locally, then by having them server-side, you'll ensure that they will always be being done, but most of the time they may be being done twice, just very quickly. Once by the dev to make sure everything's sane, and then out in your pipeline to make sure no one has skipped that step.
And again, I would argue if you've got tests that only fail when you run Beaker, when you build a real server, and that's when it always fails, then you need to think about how you can make more representative tests in the cheaper to run frameworks so that you catch those failings earlier. Again, we've always had the situation, oh, it runs on my laptop, what's wrong with it? And again, by running under the server, you can run in a regulated, controlled environment. You can make sure that you've got the right versions of the languages, the runtimes, and everything else there, which just protects that problem of, well, it ran on my laptop, why doesn't it run on the Ubuntu server? You just make sure if it needs to run on Ubuntu, these central builds are running on Ubuntu. So they have to go through the standard environment before they're accepted as validated and pass their tests. Yes?
Do you require Jenkins Enterprise in order to do everything that you've done?
So the two key features that Jenkins Enterprise would give you here is the validated merge. There are other ways you can do this with open source Jenkins, but it's not as easy to set up. And the other thing was that visualizer on the workflow. So you can have workflow itself, that's open source, but you don't get the great visualization. You get like a tree view, and you don't get the restartable checkpoints. We kind of needed to justify our spend on giving it to the community with some advanced features as well. So that's the only stuff that you haven't got.
Any more? Okay. Thank you very much.
Thank you very much.